Hello everyone, my name is Schina and I'll present you a project that I carried out together with Vanessa Esteve-González in the framework of my master's studies at the University of Rovira and Virgili in Spain. Our project is entitled Designing an Introductory Lesson to Scratch Programming Language within the framework of STEAM education to reinforce primary school pupils' computational thinking. We consider that it's really important to introduce programming into primary school curriculum. Children should get familiarized with computer programming at an early age. Nowadays, there's a growing demand for personnel in the field of computer programming, and for this reason, children should be equipped with skills in this area. There's a lot of work to be done in the field of computer programming school curriculum. Lesson plans, resources, and guidelines for teachers should be designed and implemented. In our research, there are three key concepts: computational thinking skills, skills in the area of STEAM education, and best practices to teach Scratch programming language. First of all, when it comes to computational thinking, it's a fundamental skill for everyone, not just for computer scientists. Computational thinking is a key ability associated with a variety of disciplines as science and mathematics. When it comes to STEAM education, it combines 5 disciplines: science, technology, engineering, arts, and mathematics. STEAM is a cross-curricular teaching model and aims at creating knowledge as a whole. Scratch is a programming language developed by the MIT Media Lab, and it can be taught through exploratory, project-based, and storytelling teaching techniques. Here you can see our research objectives. The first objective is related with the students acquiring skills in the area of computational thinking and STEAM education, and the second objective is related with improving the teaching materials and structures. The research took place in a non-formal educational institution that is located in Thessaloniki, Greece. There were 27 students, 15 boys and 12 girls. The average age of the participants was 9.5 years old. The present research follows design-based research methodology. The project evolves as improvements are introduced in every cycle. In this study, the researcher is the teacher too. When it comes to the teaching materials, a lesson plan was created and divided into 3 parts. The first part aims at getting children familiarized with Scratch digital environment and basic programming blocks. The second one gives children the opportunity to create short programs and develop their programming and debugging skills, while the last one gives children the chance to experiment with different programming blocks and create their own animation. The objectives, the content, the structure of the lesson, and the activities were described. In addition, a worksheet was created for the second part of the lesson, and it contained graded challenges that were completed by the pupils. Here you can see the results of our research. Our students developed skills in the area of STEAM education. When it comes to science, they were introduced to the concepts of speed and time. When it comes to technology and engineering, they created and debugged simple programs. When it comes to mathematics, they did calculations. And when it comes to art and design, they used a range of materials creatively to design and make products. As far as the computational thinking skills are concerned, in the first part of the lesson, the students studied a complex system as a whole. They understood the relationships within the system and communicated information about the system. In the second part of the lesson, the students worked on troubleshooting and debugging. And in the third part of the lesson, the students chose effective computational tools, defined systems, and managed complexity. If you take a look at the table, you will see the changes implemented throughout the research. The worksheet was improved, a supplementary poster was created, and collaboration in the second part of the lesson was introduced. Here you can see the conclusions of our research. First of all, when it comes to the skills that the students acquired in the lesson that was designed, And then, when it comes to the process of improving the teaching materials and teaching strategies. Here you can see our suggestions to future researchers. First of all, it's highly recommended to introduce computational thinking with unplugged activities and incorporate a variety of visual materials. Researchers should study in greater depth collaboration scripts and ask pupils to carry out more tasks in pairs. Researchers would be advised not to adopt the role of the teacher. It would be better for another person to teach the class and the researcher to observe the pupils and the lesson. It's highly recommended to implement the research in other contexts, for example, to carry it out in a formal educational context in a public school and with a larger sample for a longer period of time. Thank you very much. We're looking forward to your comments.